Alright, we are moving on to 8-2 here. This is special right triangles. This one is going to be one of the harder sections of the entire book. It is mainly because you've got to memorize certain parts of a triangle, these two special right triangles, as well as deal with radical signs. So this first box here deals with a 45-45, 90-degree triangle. Well, of course, if you've got two angles that are the same, 45-45, that means two of the side lengths are the same. And there's just this relationship when it's a 45-45, 90-degree angle. If you are opposite one of the 45s, you are the letter variable, any number. It could be like the number 7, the number 8, whatever. The other 45-degree angle would be the same number, because obviously this is an isosceles triangle here. Now when you get to the opposite, the 90 degrees, it is going to be whatever this number is multiplied by the square root of 2. Doesn't seem that hard. So if this was the number 5, this would be the number 5, and this would be the number 5 radical 2. But it does take a while for you to just get comfortable with this. The problem is when you come to the actual problems in the book, they will give you some numbers that aren't going to be as easy as the number 5. They might give you a radical sign, and so you're going to be taking a radical sign and multiplying them by radical 2, which can throw things off. That's for the 45-45, 90. There's also the 30-60, 90, which of course is not an isosceles triangle. The smallest side length is going to be opposite the 30. And whatever that is, that's kind of your starting point. That will be n or s. It's just some variable. It could be the number 6, the number 5, doesn't really matter. Opposite the 60 degrees would be take that number and multiply it by the square root of 3. And then opposite the 90 is take whatever this original starting number is and then multiply it by 2. So if I say opposite the 30 is 4, then opposite the 60 would be 4 radical 3, and then opposite the 90 would be 2 times 4, 8. Again, it looks really easy, but they might say, instead of just saying I'm going to start you with 4, they might give you I'm going to start you with this number, opposite the 60, or they might start you with this number, opposite the 8. Or they might start you with a number that has a square root sign. So there's patterns that you've got to discover in this section, as well as dealing with radical signs. But first you've got to memorize what is opposite the 30, opposite the 60, opposite the 90. Let's try one of these problems here. Number 1, this is a 30-60, 90. There's the 30-degree angle, there's the 60-degree angle, and then there's the 90-degree angle. We are given opposite the 90. That's our starting point right here. 4 radical 3. What you want to do first is always try to get the number that is opposite the 30. But they give us the side that's opposite the 90 to start with. So this guy here, to get from here to here, you want to, this is 2 times bigger than whatever opposite the 30 is. It is 2n. So this is really like 2n. So just divide by 2, and then this is 2 radical 3, and that's n. That's what the value of opposite the 30 is. N is 2 radical 3. So in this picture, 2 radical 3. They're using the letter x here, but it's no big deal. Now that you've got the number that's opposite the 30, you can figure out the number that is opposite the 60. Well, what is that version? That is n times radical 3. Well, I know n is already 2 radical 3, and so you're going to take that number and multiply it by another radical 3. So now you notice things are getting more confusing. This is 2 on the outside. 3 times 3 on the inside is 9. Radical 9 is the number 3, so this is 6. So opposite the 30 as an answer is 2 radical 3. Opposite the 60 is 6 inches. Opposite the 90, which is where you started, was 4 radical 3. Double that to get to 4 radical 3. Multiply this by radical 3 to get to the 6. But you'll notice how strange some of these answers look. Okay. Let's try number 2 here. A square garden has sides of 100 feet long. You want to build a brick path along a diagonal of the square. How long will the path be? Rounded to the nearest foot. So you've got this garden that's a square. 100 feet. 100 feet, of course, all the sides of a square are 100 feet. you want to figure out, you want to draw this path that is the diagonal of the square. We're going to try to figure out what this is right there. Well, there's kind of two ways to do this. You can just notice, although I drew a square, really just focus in on the right triangle there here at the bottom. And you can go a squared, b squared, c squared. 100 squared plus 100 squared is equal to c squared. And then get that result. This would be 10,000 plus 10,000 x squared, 20,000, the square root of 20,000, which I don't know what that is. Let's throw this in the calculator. 20,000 square root, 141.42, and that would be the pathway. If this is 100 feet, this would be 141 feet long. The other way to do this is recognize the fact that this is a 100 and 100 means it is a isosceles triangle. It's actually a 45, 45, 90-degree triangle. Opposite the 45 is 100. Opposite the 45 is 100. Opposite the 90 would be an 100, 100, 100 radical 2. So this would be 100 radical 2, and that's your answer as well. But they want to round it to the nearest foot, so if I go to the calculator and go 100 times radical 2, you get 141, which is what we had here. So this is the same as 141 feet. I'm rounding it to the nearest foot. Okay, and that is number 2, where you have a little word problem.